Good evening, sir. My name is A. Pujya Lekana. My roll number is 405. Now I am going to tell a seminar about what is a random process. A random process is also called as a stochastic process. It is a collection of random variables that can change with time. In simple terms, it is a time varying random signal. And there are a few examples of a random process. The first example is a message signal in communication. Second one, backward noise in a receiver. Third one, variations in weather. Fourth one, speech or music signals. Why do we use the random process? We use the random process to study signals that change unpredictable with time, such as noise or message signal. We cannot fully know their behavior, only their statistical properties like average, power, and variance, etc., can be known. Hence, they are described statistically, not deterministically. Statistically description. Because the exact value at every moment are unknown, we describe the process using the statistical measure such as probability distribution functions. It means PDF gives the probability of different values. And the next one is probability density function, describes how these probabilities are distributed. These functions tells us everything about the randomness or statistical behavior of the signals. Energy and a correlation. Random process has infinite energy because there exists over all time. So instead of total energy, we study finite energy functions like correlation function and covariance function. Correlation function measures how similar the signal is to itself at different times. Covariance function measures how two random signals vary together. This helps us understand the time domain behavior of the random processes. The examples of the random covariance and the correlation. Common examples of the random process includes speech and music, background noise, change in weather, variations of received signals in the communication system. A random process is a time-varying random phenomenon described statistically using tools like PDF, small PDF, correlation, and covariance, which helps us to understand and model signals such as noise and message signals in the communication systems. A random process is temporal characteristics. The definition. A random process or a stochastic process is a process in which random variables depends on both the time and sample space. The time. How the variable changes over time. Sample space. The random outcomes from an experiment. So a random process is written as a capital X of small s comma t or simply capital X of t. Here, um, small s is denoted as represents the randomness. It means sample point. Small t is represents the time. That means for every random outcomes s, we get a different signals function of time. Different forms of a random process where time of t is fixed. You only look at a particular instant of time. The random process becomes a random variable because of two randomness remains represented as a capital X of s comma t1. This shows the random value of the process at a time t1. Example: noise voltage measured at one instant but may differ each time you to repeat the signal. Second one, what when the sample space S is fixed, you are looking at one particular outcome. It becomes a real function of time. It is represented as x, capital X of small s1 comma t. This means for one specific experiment S1, how the signal changes over time. Example, the waveform of one realization of a random signal like one recording when both time and sample space are fixed. Both are given specific values, so it becomes as constant. It is represented as capital X of small s1 comma small t1. Example, the value of a signal at a specific instant in one experiment. These are the conditions and representation and nature and example. The first condition, time variable, sample space variable. Representation of these is capital X of small s comma t. Nature is random process. The example is random signal. The next condition is time fixed. The representation is x of capital X of small s comma small t1. The nature is random variable. The example is noise at a particular instant. Sample fixed. Sample fixed representation is capital X of small s1 comma t. The nature is time function. The example is one noise waveform. The condition is both fixed. The representation is capital X of s1 comma t1. Nature is constant. The example is single value. Thank you, sir.